Welcome to lesson 1.1 and 1.2. The goal for these lessons is just to solve basically simple equations. So the rules that we're going to use for solving simple equations like this are the addition and subtraction properties of equality and the multiplication and division properties of equality. So what this one means, addition and subtraction, is if I add or subtract the same thing on each side of an equation, the result should be an equivalent equation. So we can use that to work backwards. Addition and subtraction are opposites of each other, so they'll get rid of each other. So I don't want that plus 3 by the x. I'm going to subtract 3. Now, one thing you might be thinking is, can I just try to think of what I can substitute in for x? In something as simple as this, yes. But it's not how I want you to think, because moving forward, that kind of thinking is going to be dangerous and make what we learn in the future a lot harder for you. So I want you to start thinking in terms of these undoing steps. We'll talk about order of operations and strategies later, but for now, just laying out the rules. So the multiplication and division property, when I multiply or divide both sides of an equation, so let's say I'm going to multiply both sides by 2, which really doesn't make sense for solving this, but just to show off the rule, each term gets multiplied by the number. So up here, I just subtracted a 3 once on each side. Down here, when I multiply by 2, it actually affects each term on its side of the equation. So everything got multiplied by 2. These are the same equation. And if I were to go ahead and solve this, subtract 6, 2x equals 8, and then divide by 2 on both sides, I would get x equals 4, just like I did earlier. So I did a weird roundabout way that doesn't really make sense. If I ever saw someone do this on a quiz or a test, I'd be like, what are you doing there? But that just shows off that the property works. So no matter what I do, as long as it's a legal math step, I should still meet up at the right answer. So the first actual textbook examples to look at are these 4 right here. So you could find them with the textbook explanations on pages 4 and 5. I'll always try and show you what pages they're on in case you want to read it instead of just listen to me talk about it. But this first problem should be easy to recognize what we do. Adding is the opposite of subtracting. This is the addition property of equality. So adding 3 to both sides should get x by itself. Solving these types of problems is always about getting the variable by itself. So negative 5 plus 3 is negative 2. And we're done. The second problem, variables on the other side. All that's happening to the variable is it's adding 2.8. So if we want to get the variable alone, we have to do the opposite of adding 2.8, which is subtracting 2.8. So this is going to go away. But 0.9 minus 2.8 is going to be negative 1.9. And that'll be our answer for y. Down here, we have multiplication and division happening. There's something kind of weird about this one, which is this little negative sign over here. When you have a negative in front of a fraction like that, the way it works is it's kind of like multiplying the whole thing by a negative 1. You can kind of choose what you want the negative to be with. So whether the negative is with the n or with the 5, really it's still the same thing. So I'm going to treat it like it's a negative 5. And since n is divided by negative 5, you don't have to look at this like a fraction. You can look at it like division. If I multiply both sides by negative 5, that should get rid of that denominator. So n should be by itself now. Negative 3 times negative 5, negative times a negative is a positive, so I get a positive 15. And last example, 1.3z, that means multiplication, equals 5.2. Opposite of multiplying is dividing. So the 1.3's will cancel out there. And 5.2 divided by 1.3 is just 4. Z is by itself, that means the equation's solved. Okay, so these were all just one-step equations, making us use our properties of equality. So again, I don't want you to play the number game where you try and think of what could fill in the variable to make the equation work. Get in the habit of thinking in reverse operations, undoing your steps. Here we've got our first word problem, application problem, whatever you want to call it. So it says in the 2012 Olympics, Usain Bolt won the 200-meter dash with a time of 19.32 seconds. So there's a few numbers for us. Write and solve an equation to find his average speed. Nearest hundredth. All right, so that's a little bit of a reading skill right there for math is 2 decimals. And then of a meter per second means our final answer should have units of meters per second. What's kind of neat about these units is it really guides what we do with the numbers we have. So we need something with meters in it, and we need something with seconds in it. Well, we have the 200-meter dash. We have 19.32 seconds. So since it's meters over seconds, I need to have meters on top and seconds on bottom with the numbers and the units I have in the problem. The year 2012, that number, that doesn't do anything for us. That's just context. It doesn't matter if it happened in 2012 or 1912. This speed comes from the distance he ran and an amount of time. So speed equals, in this situation, how far he ran, distance, over the amount of time it took him, 19.32 seconds. So this is going to make the units meters over seconds. So to solve this equation, really we're just going to divide. There isn't actually an algebra step to do. This problem is more about being able to represent something with an equation, which means variable equals some sort of expression. All right, so if we divide 200 by 19.32, we'll get our answer. So we'll whip out our handy dandy phone calculator that I'm going to expect you guys not to use. And we get 10.35. Again, I used 2 decimal places because that's what the problem asked for. So S equals 10.35 meters per second. All right. So the kind of format I like to use is what do we know? And I kind of annotate a little bit to figure that out. Otherwise, on the regular notes I give in class, I just leave spaces for us to write that stuff down. What do we want to know? They wanted us to find meters per second. They wanted us to find a speed with those units, and that kind of guides what we do with our numbers. And then actually solve. So we identified useful information, we found out what we wanted, and we tried to do something that made sense to find that answer. All right. Our next short conversation is going to be about inverse operations. And all this really means is what math operations are opposite of each other. So our 4 basic math operations are addition, subtraction, multiplication, and division. So addition and subtraction are inverses. And that means in equations, we should be able to use them to undo each other and try and get a variable by itself. Same thing with multiplication and division. These are inverses as well. Now, while we're looking at this, I want to talk a little bit of strategy with you for solving. And where that starts is looking at order of operations. So that's the whole PEMDAS thing. And I'm writing it weird like this because multiplication does not actually happen before division. In an equation, these two would happen left to right. Same thing with addition and subtraction. Addition does not actually happen before subtraction. When you get to that point in an equation, they would happen left to right. All right, so multiplication and division, addition and subtraction, those things are paired. These are inverses of each other. All right, so if I give an equation like x plus 3 with times 5 in front of it equals, we're gonna put, just trying to think of something that would make a good number, a 20 over here. Okay, so if I get rid of this 20 and I tell you to plug something in for x, I tell you to plug in like x equals 4. All right, if I tell you to plug in x equals 4, what are you going to do with it? We want to replace x with 4, and then we would follow order of operations. So we would start inside the parentheses. 4 plus 3 is 7. And then we would get to multiplication. 5 times 7 is 35. And that would be what we come out to. So when you plug a number in, following order of operations is what I want you to do to solve. All right, but for solving an equation backwards to figure out what a variable should equal, it's going to look a little different. It's actually going to look almost like the opposite of this. All right, so we're going to try and tell what can we do working backwards. So right now, is there anything that's added or subtracted that we can undo? You might be looking at this and think yes, but it's inside of parentheses. It's kind of like guarded. What we need to do to open up that parentheses is either distribute the 5 in or divide the 5 off of that side. So let's divide the 5. So multiplication or division, is there anything on this side of the problem that's appropriate to divide? Yep, we can divide a 5. So earlier when I said we have to divide every single term, this is actually all just one term. We'll talk more explicitly in the future what the difference between terms are and the different layers of an equation like inside the parentheses here, but this is a good time to divide by 5. Some of you might be more comfortable using the distributive property. That's fine. But here I'm going to divide by 5. And now x plus 3 does not have anything around the parentheses, which means I can just get rid of those guys. So now we look backwards, now that our parentheses opened up at our order of operations. Is there anything easy to add or subtract? Yes. Subtracting 3 on both sides would get us x equals 1. So one strategy, one way to think about this is actually think about order of operations backwards. Is there anything easy to add or subtract to cancel something out? Multiply or divide. Exponents we'll get to, it's like chapter 6. That'll be a ways down the road. But then parentheses are usually going to be the last thing we take care of ever. So like here, I got the 5 away before I did anything with the x plus 3 that was in parentheses. So in equation solving, one strategy is to try and get any parentheses by themselves so that you can open them up. Because as soon as there's nothing around the parentheses, you can just open up the parentheses. So following order of operations backwards lets us undo things in a way that's easiest, and the inverse operations are what help us make those undoing steps. Here's a couple more examples for us to look at, and these are 2-step equations. This one is 3 steps, but only 2 of them are really algebra steps. So the strategy is opposite of order of operations, which basically means look for easy things to add or subtract first. So our goal is to get x by itself. What's all the stuff on the x side getting in the way? Well, x is multiplied by a 2.5, and that's subtracted by 13. Getting rid of the subtraction is going to be the easiest first step. So the opposite of subtracting is adding. And we end up with, if I don't erase it anymore with my hand, 2.5x equals 15. Now x is multiplied by 2.5. The opposite of multiplying is dividing. And 15 divided by 2.5 is 6. Solution to that equation is 6. This next problem, I'm going to follow kind of the same pattern, but the first thing to notice is there's more than one x on this side. We're going to combine like terms there. 9x minus 6x is 3x. And now we're going to solve it just like the last problem. Okay, so every once in a while we'll have a little cleanup step like that to do. I wouldn't call it an algebra step necessarily, but a cleanup step. So here, x is multiplied by 3, and then that adds 15. So in this situation, I would subtract first, because that should be the easiest thing to get rid of. Negative 12 minus 15 is negative 27. And now the only thing left happening to x is multiplication. The opposite of multiplying is dividing. Negative 27 divided by 3. A negative divided by a positive is still a negative, so that'd be negative 9 equals x. Now that x is alone, that's solved as well. So this just shows off that idea that opposite order of operations is the easiest way to solve an equation. We'll talk about a different strategy in just a second. So this brings us to an example where there's multiple ways to solve it, multiple good ways. And one of them is the distributive property. The other is the strategy I was using where I would get the parentheses alone. So let's do this first one like I was doing before, get the parentheses alone first. What's happening to the parentheses? It's being multiplied by 2, and then after that it's being added by 3. So we're going to start with addition and subtraction. That's the easiest thing to undo. Everything else on this side stays besides the 3 we got rid of, and negative 8 minus 3 is negative 11. So now we would divide by 2. Negative 11 divided by 2 is negative 5.5. 1 minus x equals negative 5.5. All right. Now this is kind of weird. This takes a little bit of getting used to. But this is a positive 1 with a negative in front of the x. So in this situation, I would subtract 1. The 1 is a positive. We need a minus 1 to get rid of it. So negative x equals negative 5.5 minus another 1 is negative 6.5. And then to get rid of that negative, we just divide or multiply by a negative 1. Basically, both of these switch signs. So negative x equals negative 6.5. And I'll make those both positive. X equals 6.5. Now this is the same equation, so I should expect the same answer. All right. But we're going to approach it a different way. So this different way, I'm going to give you a new first rule to follow. So when applicable, this should be your first step. The distributive property wherever you can use it. Distribute everywhere. So the distributive property means multiplying this 2 into the parentheses by multiplying by both things in the parentheses. So 2 times 1 is 2, minus 2 times x is just 2x, plus 3 equals negative 8. Now on this side of the equation, I have a positive 2 and a positive 3. Those are like terms. Positive 2 and positive 3 makes a positive 5. Now I can subtract 5. Negative 2x equals negative 13. And if I divide by negative 2, I get x equals 6.5, which is the same thing we got before. So the takeaway here is as long as you're doing legal algebra steps, legal math operations, everything should always agree with itself. All right? There are things that are illegal math operations, which could include just doing your algebra step wrong, making a math mistake, or things like dividing by 0. That's something we just can't do. So let's count the number of steps each of these took. Subtracted 3, divided by 2, subtracted 1, divided by negative 1. And then up here, distributed, combined like terms, subtracted 5, divided by negative 2. So would you consider one of these better? They both took about the same amount of time. I don't know. I guess that's an opinion thing, isn't it? So I do like to do the distributive property myself when it's easy. Other times, dividing by what's in front of the parentheses, like we did up here, getting the parentheses alone first. Yeah, I do it both ways sometimes, but usually I do the distributing method. Here's our last problem for the lesson, and it's another one where we write out our own equation. So if we read this, your school's drama club charges $4 a person for admission to a play. The club borrowed $400 to pay for costumes and props. After paying back that loan, they had a profit of $100. How many people attended the play? All right, so things that seem useful. $4 a person, borrowed $400, so that's money we spent, not money we're making. At the end, we ended up with a profit of $100. We had $100 more than we spent on those props and costumes. How many people attended? All right, so in this situation, we have $4 per person. So $4 times the number of people that attended. We're going to say P means people. That should be how much money we brought in. All right. Now we had to pay back a loan. So if we're paying back a loan, is that money we're getting or money we're spending? That's money we're spending. So we have to think if that's going to add or subtract from the money we're bringing in from those ticket sales. So that's money we're subtracting. And then we should have a profit of $100. So let's think about this. This is money we made. This is money we spent. Where should that $100 go? Well, the money you make minus the money you spent should equal your profit. So that's going to finish off the equation. So this is the profit. So in money situations like this, when you're talking about profit, this is going to be a pretty typical format for an equation, is how much did we make, how much did we spend. That should equal the profit. So this is our equation. Now I'm going to take the dollar signs out for now and just leave the numbers, but I'll put the dollar sign back in at the end. So this is $4 per person times the number of people, and we want to figure out how many people bought tickets. So now this is just a normal algebra equation. Out of context, this should be really easy for us to solve because it's just a normal two-step problem. We'll start by fixing addition and subtraction. I'll add 400 to get the minus 400 away. Sorry, wrong symbol there. So now 4p equals 500. Now let's think about this step here. If we spent $400 and profit $100, how much did we have to make? That's what this step is telling us. So basically, if we use a little bit of logic, we could have gotten to this point, is that we had to make 500 to profit 100. So now we divide by 4 to figure out how many people had to buy tickets to get $500. P equals 125. So we must have sold 125 tickets. All right, 125 tickets. Or in the problem, it specifically says how many people attended. So I should probably put the word people there instead of tickets. Just like our last problem, I want to use that to guide my units. Our units should really be dollars and people, nothing else, because it doesn't reference anything else. So that is the solution. Okay, so again, this whole idea of what do we know, what is the problem asking us, and then trying to write out an equation that makes sense. So we'll start to notice patterns with these equations. When it's a profit problem, it'll be how much did I make versus how much did I spend. That should equal my profit. And there will be other common ones that I'll try and point out for you in the future. Math is all about identifying patterns, so that'll be a way to shortcut things sometimes. All right, feel free to rewatch the video if anything didn't make sense. Otherwise, save questions for the class period.